Hello, this is Mr. Fraley again with a new guided practice video. Today, we'll be looking at the balanced equations assignment. Now, last time we talked about the parts of a problem and how to build an equation from a problem. I think that is a crucial skill in solving any of our word problems in algebra, is being able to take kind of an explained situation and turning it into an equation you can do math on, right? You can use your algebraic tools with. Even when I worked at a university, I encountered students who could not do that. So the last video was focused entirely on learning how to build our equations. In this video, we're going to do what people typically think of as algebra, as just the actual solving of the equation, finding the value of our variable. Remember last time, y and q were letters that we did not decide a value on. It was kind of left as just a mystery letter, right? It was a placeholder for some number we didn't know. Today we're going to learn how to figure out what that number is without guessing and checking or any of that messy stuff, right? It's just two quick and easy steps using language we've already learned to drill down and find out, in how many years will that tree be 100 millimeters or thick, or in how many quarters will get me to $7.50. So, right. This will work really for any problem that you'll encounter this year, just these two simple steps. So before we get to that, I want you to we're really going to work on what an equation is, right? So think of an equation as a balance scale. Both sides of the equation need to weigh the same, or in math, we will say they have the same value, right? Here we have one side of the box that weighs 4 pounds and two stacked boxes with the same weight. We call it x pounds, but we don't know what they are. Because there's two boxes, we just say 2x. Okay? On the other side is another box that weighs 14 pounds. Now in reality, both sides weigh a total of 14 pounds. But one part is a single, clearly labeled box, and the other side is kind of in parts with sort of some unclear labels we have to figure out. Okay? So, with that said, let's look at the next picture here. To keep our scales balanced, if we take the 4-pound box off the left side, we must also take 4 pounds off our 14-pound box. So we must take the same amount off of both sides to keep my equation balanced. The remaining weight on the right side is now 10 pounds. So we went from 14 down to 10. Okay? So all we have left is the 2x, or the 2x pound boxes. As much as I'd love to call them x boxes, I don't want to confuse anyone. We have 2 of my x pound boxes, like that. They weigh the same, equals my one 10-pound box, right? So we don't know what to subtract, okay? We don't know what to subtract because this might be like x plus x or 2x, right? But there's no value we can subtract. But we see there's two of them. There's two groups of x pounds. And one way we can get it down to just a single x is to divide it in half, okay? If there's 2 and you divide it in half, you'll get just, the one group, okay? So what we do to one side to keep my to keep my scale balanced, what we do to one side where we, halved it, or we divide it by 2, or however you want to say it, we're going to do the same thing on this side. So what is half of 10? If we think of, if we had 2 boxes that both added up to 10, we could say they both had 5 pounds. So at this point, my images are actually very similar because they're describing the same thing. Here we've gone from a single box of 10 to 2 boxes of 5. And we have 2 boxes of x, and they're the same. So that means that x equals 5. Okay? And so that's our solution. I said there were 2 steps, and we really only did 2 steps. One step is we subtracted my starting amount. That was 4. Subtract the starting amount. I didn't write this when I was in the class with y'all, but I want to write it this time, just to be clear, from both sides. Subtract from both sides. Always, always, always in algebra, what you do to one side of an equation, you must also do to the other side of an equation. Okay? So we subtract the starting amount from both sides. And our next step that we did was, remember we divided by 2? Remember my rate is what I multiply by my variable. So my variable and my rate's right next to it. In this case, my rate was 2. We always divide, we will always then, secondly, we divide by the rate. Divide by the rate on both sides. And these are our 2 steps. First time, we subtracted 4, and the other time, we divided by 2. Those were our 2 steps. We subtracted the starting amount, we divided by the rate. I'm going to say it over and over again because it's just that good to remember. All right. So let's use this on some problems we've looked at before. Let's look at the tree problem, and you'll find that on the next page. My answer for the first page was x equals 5, because that was half of 10. On the next page, we see we're going to solve the growing tree problem. Let's look at the, in the previous demonstration, we found the value of x by removing everything from the left side of the equation till only x remained on one side and a number was on the right. Let's look at the tree problem we did earlier this week. We found a tree that started out at 60 millimeters thick and then grew 2 millimeters per year until it was 100 millimeters thick. There. How much thicker did we want our tree to be? So when I say how much thicker, how much more, right? I want to know about the difference between the starting thickness and the final thickness, okay? So my starting thickness was 60 and my final thickness was 100. So what is the difference? How much did it grow? That's right, it grew by 40, okay? So that's kind of, because to talk about how long it takes to grow that much, we need to talk about, you know, how much we're growing, right? So we started off at 60, and then we wind up at 100. Okay? It's going to grow out from there. Okay. So to find that, let's take that equation we thought of last time. We had 60 plus 2x equals 100. Remember, we found the difference. That's a code word for subtraction. So what we did, we subtracted 60. Or really what we did was we subtracted the starting amount from both sides, and that was my first step. Subtract 60 from both sides, my starting amount. And so 60 minus 60 goes away. 100 minus 60 will become 40. So we're left with just 2x equals 40. It's starting to look a little familiar. Remember we saw 2x equals 10? You got rid of the 2 by dividing by 2. Because it's multiplied, we're going to divide. Earlier this was added, so we subtracted. This is multiplied, so we divided. Those are our sort of inverse, we call those inverse operations. Every operation, like addition, has a subtraction. That's its inverse. Multiplication has division. That's its inverse. So here we divide by 2, we get x equals 20. Which, oh no, we had a y. Should write a y. Because that was our answer. Remember y? Right. So these were the two answers on this page, 40 and 20. Okay? And so we found that it took 20 years to go from 60 to 100. 60, and the thing is, with algebra, you can actually check your work. You can plug your 20 right back in, right? 60 plus 2 times 20. 2 times 20 is 40. 60 plus 40 is 100. Okay? Very good. So that's, here we see it used on one equation. There's no guessing and checking. I know in class, if people looked at this, some students looked at this and they outright, if I asked them how many years without teaching them this method, they'd look and they'd just say 50 because they see 2y equals 50. But we have to include this. Both steps are important. You have to subtract to find how much we're growing, and we need to divide that growth by the rate, and that gives you just the variables. Okay? So, that all being said, we're going to look at the next one. The next one, we're going to look at the quarters problem. Remember, my equation was 4, let's write like the way we write $4, plus 0.25 times the number of quarters. I'm not going to write the multiplication dot. I want you to get used to having just a q there. To say 20.25 times q. Whatever that number is. You don't know yet. It's equal to 750. Okay? So we subtract. Oh, let me make that decimal clearer. Not the best quality video. Okay? So we remember our two steps. The first step was subtract the starting amount. And what that's going to find is how much her quarters need to add up to, right? Because you have 4 and you have 750. You know, oh, I don't have 4. I just need, how much more do I need? I need $3.50 more. I need that much money in quarters. And to get me there, and that was the thing that, you know, you might just do in the real world. You subtracted 4 to focus in on how much our quarters need to be. Note in the picture I showed a pile of bills and a pile of quarters. We know that would have to add up to 750, but we're more curious about the quarters. So we want to take those bills out of the picture and focus instead on what the quarters add up to. So the quarters, 25 cents times those number of quarters, should sum up to $3.50, or should the product there is $3.50. So the first step was subtract the starting amount. The second step is divide by my rate. So divide by 0.25. Divide by 0.25. Now, some of you may be intimidated by a division problem with decimals. Okay? And earlier we saw 10 divided by 2. If you know your division facts, you know that's just 5. We saw 40 divided by 2. We know our division facts, that's just 20, right? And that was pretty clear and like we knew it wasn't 1/20th, we knew it wasn't 1/5 because that didn't really feel right. But some of us might not be too clear on how to turn a fraction like this, especially with decimals, into a division problem. So for one, okay, we're gonna solve Q. We know Q equals 3.50 over 0.25, whatever that is. We're gonna figure out what that is. So let's write that out. This is gonna be a little bit of an arithmetic review. Y'all, I know y'all learned this in a previous school year. It's been a while, we might have forgotten. So we have 3.50 over 0.25. And I apologize for that. And we want to know how that's going to work out for a division problem, right? You know this is going to be long division if I've already said it's division. But what goes where? Well, what we have here, I want you to imagine a cowboy or a guy on a horse, right? Even people who can draw have trouble drawing horses, so give me a break, right? So this here is our bank, and my cowboy is going to go in the bank. So he's going to go inside of the bank. Here he is, doing his cowboy business at a bank, getting the money from his last job. He goes into the bank, and where's the horse? The horse is waiting outside. Okay? It's just a funny sort of visual that stuck so well with me that honestly it's what I think of when I think of dividing decimals. I think of a cowboy going into a building and a horse waiting outside. So now what's to be done about the decimals? And here's what we do. We are going to move our decimals over until we don't have any more decimal numbers left. So here, my 0.25 is going to move over once. And my 3.5, that's going to move over once. Now it's 2.5 and 5.0. There's still a little, this is still a decimal, so we're going to move it over one more time. Now we just have 25. I'm going to move this over one more time, and we have 350. And my new question becomes 25, the decimal moved over twice, into 350. There, that's $3.50 with the decimal moved twice. So we move twice in both cases, and then we divide. So 25 goes into 35 once. 25, subtract 100. 25 goes into 104 times, cleanly with no remainder. And here we have 14. So my answer is 14 quarters. Okay? Remember, Q equaled 3.50 over 0.25, which we've simplified to the number 14. The other way to think of this, I included a hint on the page. You can think about how many quarters is $1. Well, it's 4 quarters in $1. Right? 4 quarters in $1. So we've got $1, $2, $3, 4, 4, 4, and then we had 50 cents. And so that's 2 more quarters for the 50 cents. Okay? So 4 plus 4 plus 4 is 12 plus 2 is 14. So that's 14 quarters. It's another way to think of it. So 350 is 14 quarters, which is my answer. And really, my 2 steps were subtract my starting amount. So I subtracted 4 to find the number for the quarters, and I divided by my rate, which was 0.25. That got me to 14 quarters. And that's it. That will pretty much be a pretty useful method for solving really any problem that you'll encounter. There might be a couple more steps we'll talk about soon, but for now, that's going to pretty well get the job done. Thank you all for watching. You all have a good day, and I don't know. I don't really have a sign-off phrase.